Hello, is this working? Nice. Hey, I'm Mathias. I'm gonna talk a little bit about Bittorrent, streams, and JavaScript. So that's gonna be nice, hopefully. So let's get started. So like I said, I'm Mathias Buus. I usually hang out on Twitter and IRC under Macintosh. Besides working a lot with Bittorrent and stuff, I do a lot of Node, and you can find all my Node stuff on GitHub, github.com/Macintosh. So, yeah, I'm from Copenhagen, by the way, and it's nice being in Norway. Kind of similar, but super cool. I was expecting it to be a little bit colder, but I'll survive. So, yeah. Things I'm going to talk about. First, I want to give a little introduction to, just what is Bittorrent, because I think it's the kind of thing that kind of has a... When people think about Bittorrent, they usually just think like, oh, that's the thing I use to watch Game of Thrones. But it's actually way cooler than that. And I want to talk a little bit about just how it works and why should you care. Then we're going to talk a little bit about, how can we make this stream? And hopefully I'm going to show some demos that's going to work because the network will work, hopefully, crossing my fingers. Finally, I want to talk about mad science. And I'm hoping to do some crazy things that might or might not work, disclaimer, but hopefully. All right, so let's get started with Bittorrent. Yay! So let's look at a scenario here. So imagine you have some sort of really popular video file. It could be, I don't know, an HD video of a train going from Oslo to Bergen that's like really awesome, and it's huge, and it's sweet, and it's public domain. You have that file, or someone has that file, and you're thinking, it would be really cool if I could take this file and give it to people. And the very classic way of doing this is that you take this file and you put it on a server, and you have a client, and he calls that server and he says like, dude, I want to watch the train. And he fetches that file from the server. So this is pretty cool because it's really nice and simple, right? So trains are cool, and this is going to get really popular. And 1 million people, a fifth of the population of Denmark, is going to come in and I want to watch that train. So what happens then? Every client is calling the server, and they're like, give me the file. And the server's like, yeah, give me the file to this guy, and give me the file to that guy, and 1 million people. So we could maybe scale this up, add more servers, but at some point, people kept coming, and the only natural thing that's going to happen is that the server's going to blow up. Boom. So that's really not cool, because now I can't watch my train anymore. And so what can we do? So simple idea. How about we just take that server away and instead have all the 1 million clients kind of act as a server and send data to each other. So instead of having the server to a client, we have a scenario where we have multiple clients, and each client is sending data to each other and knows about some of the clients. Maybe not every client, because there's 1 million of them and it's going to be huge. But there's some graph that can kind of connect you to everybody. And if you want data, you just ask a client, he'll send you some data. So that's cool. So imagine now that client 1 gets really popular and he blows up because something is wrong. No biggie. We'll just fetch data from someone else. So client 1 blows up. Let's just ask client 3 instead. I mean, that's pretty cool. So we kind of have a thing here where every client is acting as a server, and we usually call that a peer. So you can even call that peer-to-peer, because it's multiple peers. So far so good, right? It's still really simple. We just have a lot of peers talking to each other. We just took away the server. But this kind of introduces a whole new set of problems, because now we're getting data from peers. How can we trust that data? How do we know that this is not a train ride from crappy Sweden, or like something else, or lower quality? We can't really trust these guys, because if we have to trust everybody, we kind of end up with the same scenario in the beginning, where we have a kind of like a fixed set of servers. So we need to fix this somehow. So what can we do? Well, turns out we can do something really, really simple. So imagine we have the big file, the video file. Someone has it. Someone starts by having it. What he does is he takes this file and he tries to cut it into pieces. So it could be a megabyte piece, and this gigabyte file becomes a million pieces instead. So that's pretty cool. Then for every piece, we just take a hash of it, and we concatenate all the hashes into one file. So we have a file that's like, the first thing is the hash of the first piece, the second piece, etc., etc., etc. So if we somehow distributed this file to every client, we could just get a piece from some random dude, and we could just hash that piece and look in our table. And if the hash matches, no problem, it's good. It's the right piece. If it doesn't match, it's probably sweet. So we fetch the data from someone else and kind of blacklist that guy. So that's cool. So we could even call this file a torrent file. We still have the problem that we need to kind of like take this file and give it to everybody in the network. And I mean, this file is going to be a lot smaller than the original file, because it's kind of like a digest of the files. But I mean, if we have a lot of pieces in our file, it's going to be a couple of megs. And I mean, we could just put that on the server, a trusted server somewhere, because we need to trust this guy, because this is kind of like the authority of our file. And this will probably scale okay. But I mean, at some point, if this file is a couple of megs, it might blow up again. It's kind of like a single point of failure into our system. So I mean, it would be really cool if we could have like a solution where we kind of had less data on the server. So this is actually really, really simple to solve, because we can just apply recursion, because this is kind of like the same scenario we had in the beginning. So what do? We just take this list of files, of hashes for each piece. We hash that again. If we're using something like an MD5 to hash it, this new hash is going to be 16 bytes of data. Like, it's not that much. It's like 16 characters or like 32 characters in hex. So I mean, we could probably just take this data and put it on a server somewhere. So if you have that data, you can just get this list from anywhere, and you can just hash it. And if the hash matches, that means that the data is correct, right? Recursion, yay. So what we do now, instead of having like all the hashes on one server, we just distribute the hashes out to all the clients. Fetch the data hashes peer-to-peer, and use the single hash, which we will call an info hash, to verify the data. Nice and simple, right? This is how Bittorrent fetches data and verifies it. Yay! So if you ever use something called a magnet link, this is kind of what a magnet link is. This is just that hash. So this I mean, this kind of solves one of the biggest problems we have. We can now distribute data, we can now fetch data, we can now build up a chain of trust. But there's still a major issue here, because remember that first graph where was all the clients? We still need to somehow find these clients. And we could just add a list of clients somewhere. See, like, this is the list of clients. Give that to everybody. That's like not that much better than just having one server, because if everybody dies on that list, we're out of luck. So we need to somehow figure out a way to find clients. Enter distributed hash tables. Yay! So a distributed hash table is kind of like just a table that's distributed. That stores hashes. So usually it's something like a key value store that just is very, very distributed, or not so distributed. So if you ever use something like Amazon Dynamo or similar tools, it's distributed hash table, key value stores. And a nice property about these things is that they usually scale really, really well. So imagine we had something like a distributed hash table for Bittorrent. Super simple. We just have every client out there try to join this distributed hash table, right? So to join this hash table, you kind of need to know how to join it. I mean, you need some sort of entry node that can kind of point you in the direction of the other nodes somehow. And what we could do is that when we distribute like the 16 bytes of data, the hash, we could also distribute a couple of nodes that is, say, like these nodes are probably up. You can try to connect to them to kind of bootstrap into the DHT. Or if that doesn't work, we'll have a list of 10 nodes in the world that are usually up. And we kind of just need one of them to be up, because the only thing he needs to do is route us to the rest of the nodes, right? So this kind of works. So we join the DHT, and we put in a value. And the value we put in is just, key is our info hash, that's just a string. And the value is just me, my address, my IP. So that's pretty cool. That means that, if you want to get peers, you just do a lookup on your info hash, and you'll get multiple peers back. And when building something like a distributed hash table, when you read articles about these kind of things, it's always like, yeah, that's pretty hard because you need to have consistency and and you can't have everything at once. We don't really care that much about consistency here, because we only need to find a couple of peers. So if we get like 10 out of 100 peers, that's still good. If we get 100 out of 100, it's really good. But I mean, no biggie. We just need some, right? And Bittorrent uses this kind of DHT, and it's huge. I mean, if you go to, there's this guy who's tracking the size of it. And at any time, like right now, this DHT consists of 10 million nodes. And just imagine the scale of that. It's like a database that has 10 million things connected to it. And it's like data floating around. So imagine trying to kill this thing. It's like you're going to go around to 10 million people and be like, you need to shut off your thing, right? It's unkillable. So that's really, really awesome. I mean, that's really, really thought out design, and it's so simple. So that's kind of how Bittorrent works. So just to sum up, it's these 5 really, really easy steps. You have a magnet link that consists of the info hash. What you want to do is you want to contact the DHT, you get some peers, you try to connect to them, you get the metadata, that's the hashes of all the pieces. You verify this metadata using our info hash. And now we start getting data. And we can verify this data using our metadata. Super simple, right? So Bittorrent is pretty sweet for sharing content. Scales really, really well. So, well, I'm a Node hacker. And I've been hacking Node for, I don't know, I want to say 5 years, since the 0.2 days, but it's so hard to keep track of these things anymore. But for a long time. And there's a couple of really, really cool things about Node that I really, really like. I like that it's async, because async code, once you get used to it, just has a really nice flow to it. It has an amazing community. I mean, you go to IRC, people are just dying to help out. It's ever growing. Just think of these conferences where everybody is super nice. And it has NPM, and I don't think NPM has any competition in the world besides like in scale and just the amount of really, really cool things that's out there. And anybody can just go to his computer and like do NPM publish. I think Substack is going to talk even about this a little bit, so that's going to be pretty, pretty cool. And one of my really, really personal favorites is that streams are a first-class citizen. finally, you can do an HTTP request, you get a stream back. Do a TCP connection, you get a stream back. Even Browserify uses transform streams. Everything's a stream. So I mean, if Bittorrent is nice and Node.js streams are nice, will combining them make something really nice? Well, I don't know. I mean, Bittorrent is cool and all, but it takes a while for stuff to download, and I mean, you have to wait for a couple hours to fetch this big-ass train movie, stuff like that. So how about real-time Node streams and Bittorrent? That would be really, really cool, right? Like being able to fetch a lot of data from a torrent in real time, like instantly, just see like, yeah, I want to watch this thing or this thing. So how do we make Bittorrent real time? Well, I have a very trivial implementation of doing that. So remember that a BitTorrent was basically just a lot of pieces of a file. So what we could do is we could just say we have a bunch of peers. Peer 1 fetches piece 1, peer 2 fetches piece 2, etc. So when peer 1 is done, it just, like the first piece here is the most critical one, right? Because we are streaming it. So when that piece is done, we just hand that over to the stream. Stream takes that and hands that over to whoever wants to read it, right? So when he's done, we do the same thing for piece 2, etc., etc., etc. Super simple. And it turns out this is a little bit too simple because it has some obvious drawbacks. I mean, what if the first peer is really, really slow? I mean, if the first peer is going to take 10 minutes to download a piece, it's not really real time because we just have a lot of latency. It might be real time on paper, but me as a user is not going to experience real time. So how can we make this better? Well, it turns out, luckily, it's really, really simple to make this a lot better. What we do instead is we just have multiple peers, right? Have them help out fetching the first piece. That way, if one of the peers are slow, doesn't matter, peer 2 is probably fast, etc., etc. All the rest of the peers can just like do whatever, try to fetch the last data. So that's pretty nice. But, I mean, if one of the peers that's helping fetch piece 1, if one of them are slow, it doesn't really make sense to try to make him fetch the most critical pieces, right? So we can very easily make this a lot better by just maintaining a list of really, really fast peers and only use them to fetch the most critical pieces. So, I mean, if you make a stream and you want to fetch the first 10 pieces, the first piece is going to be really important because that's like how we measure latency. So just have all the fast peers like concurrently try to fetch that piece and give that back to the stream. And of course, we're going to waste a lot of bandwidth doing this because maybe we're going to fetch the first piece too many times. But, I mean, we'll survive. It's only the first piece. Once we have enough critical data, then we can just like spread it out. I think that's pretty cool. And the cool thing about this thing is that if one of the peers in our fast list becomes slow, we just hot swap him from another peer. Take another peer that's fast. Swap him in there. So this is kind of the best of both worlds, which kind of makes sense, I guess. So, I mean, like I said, in general, it's not that, like we're gonna waste a little bit of bandwidth, but it's not gonna be that much because we only gonna waste bandwidth on fetching the most critical pieces. So it's probably fine. And I like this algorithm so much that I implemented a module in Node that kind of does this. And I want to try to demo that. Hopefully it will work. It's called torrent stream. So let me try to switch to a terminal. So, oh yeah. So let's try to make a thing that, giving a magnet link just reads out what files it has. So I'm going to do like list.js. Oh, and I have a prefetched magnet link here. So first thing I'm going to do is I'm going to require a torrent stream. And then I'm going to pass torrent stream my magnet link. And torrent stream is going to try to fetch the metadata, like I described. And when it's done doing that and everything is verified, it's going to emit an ready event. So I'm going to try to hook up to that. And then let's just try to print out the files that's being fetched, right? That are available in the torrent, sorry. So console log, these are the files. And we just iterate over the files in the torrent. Like this. And we just print them out. Say like the first one is file name. So file is an array of all the files in the torrent. Like only the metadata, not the actual files, only like the names and stuff. That's the only thing we get from the metadata, besides the hashes. So let's just say fetching metadata here. So hopefully this will work. Oh. Fetching metadata. Yay! All right. So this is a magnet link to a documentary that was made about the Pirate Bay. So you see here it has 3 files, which is pretty cool. And one of them is an README. So a README is a text file. So it would be pretty cool to try to just stream this text file out to the terminal, because the terminal is pretty good for viewing like text data. So let's try doing that. So I'm gonna make a new file called pipe. Just gonna connect to the torrent again. Oh, whoops. Oh, just forgot my link. So we're gonna connect to the engine again, and we're gonna, when it's ready, we're gonna take file 2, because that was the README. So I think that's index 2, I guess. Oh, sorry, file number 3, right? Anyways, let's try it. Piping out file the name. Yay. So what we do is we just make a read stream to this file. So this is basically just exposing the file in the torrent as a stream. And let's just pipe that to process standard out. So we haven't fetched any data yet. We're just saying, like, when you're done fetching the metadata, just make a read stream to the file and try to pipe that out to the terminal. So let's try to run that. Boom. So this is the README of the torrent that was being streamed to us in real time. I mean, we haven't fetched any data yet. We just said, when you have data, pipe that out to standard out, right? So that was a demo of torrent stream. I mean, this is pretty cool, but also not that useful, like in itself, my thing, because text files, I mean, that's kind of, I don't know, not very fun to stream, I guess. So yeah, end of presentation. No. What if instead we could stream the video files in the torrent, right? That would be way, way more cool, because video files are inherently streamable. If you have just a little bit of a video file, you can still view something. It's still a picture. So what if you could take something like torrent stream and combine that with something like VLC, which is a really, really good program for displaying video content? Well, I had this idea, and I built a module called PureFlix. So what PureFlix does is that it combines torrent stream and VLC, and allows you to view torrents, video torrents in real time using VLC. And it got really popular recently because a thing called Popcorn Time used it, which I'm not part of. People sometimes confuse that, but I mean, it's MIT license. That's why we have licenses, right? So No responsibility. So I want to show a demo of PureFlix because it's a really fun demo, because it's very visual. So if we go back to our example here, if we just run the list thing again, it had a video file here, right? So what we can do is we can just fire up PureFlix using this same magnet link, and what it will do default is just take the biggest file into torrent, that's the video file, and expose that to VLC. That's what the -v means. So crossing my fingers. So what it does now, it connects to a lot of peers, tries to fetch data, and the UI is a bit fucked up. And now actually it has the video, and it starts streaming this documentary in real time. I mean, we haven't even fetched the data yet. This is all happening right now. We fetched something like a couple of megs, I guess. And a real cool thing is that this also supports random access support, because, I mean, if we read inside a file, it's just a matter of offsetting our read-write, so we can do crazy shit like skipping, hopefully. Nice. Yay! And I mean, it's... I mean, if you know what's happening underneath here, it's just really mind-blowing, because this is actually connecting over HTTP to a Node program that's streaming in real time to a torrent swarm. Like, a bunch of people around the world are helping us watch this right now in real time. It's like, whoa. So I think that's pretty cool. Mad science. So, I mean, I kind of made this thing a while ago, and I was thinking, like, it's pretty fun, you know, video. I think a lot of different kind of, you know, other people have also built things for streaming Bittorrent. It's usually always video, and it's, I mean, it's kind of fun. But I made this really low-level module in torrent stream. I mean, and it would be really, really cool if instead of using VLC, you can just have something like a file viewer, right? And if you double-click that file in a file viewer, it will just open up your video file with your favorite video streaming software. It could be MPlayer, it could be QuickTime. And it should still be like happening in real time. So I mean, if we could take the files in the torrent and put them on your file system in real time, like instantly, and just double-click them, that would be whoa. And luckily, a thing called Fuse allows us to build a file system using code. So I mean, natural conclusion, if we combine torrent stream and Fuse, it's going to be like mind-blowing, right? So I did that. In a thing I called torrent mount. And the really cool thing about this is it kind of uses the power of NPM. I think it's like 80 lines of code. And the only thing it does is that it exposes torrent stream to the file system using Fuse. So what you can do is you can just call torrent stream and then pass the magnet link. And hopefully it will work. So we can just open up. Can I make this bigger? I don't know. So this is actually a file viewer, and this is the files in the torrent, right? And if I double-click this, it will just start playing. I mean, it's a torrent underneath, and it's like streaming in real time. And it's like, whoa. And hopefully skip will work. And a really, really cool thing is that, notice the subtitles here? That's because in the torrent, there's a file that has the same name as the video, and VLC will try to read that. And what happens underneath is that VLC tries to read that, and it goes out to the swarm, and someone around the world is giving us the subtitles, and it's streaming it in real time, and VLC is encoding the video, and it's like, whoa. I still can't believe this works. It's like, just too much. So I kind of tried to push it to the limit, and I don't know if I have time, but I'm going to try anyway. To be like, because you know the best thing you can use torrents for is installing Ubuntu. So I thought, what if you could install Ubuntu in real time? So I found a torrent file to Ubuntu, and I hope this works. I'm gonna mount that here, and I'm gonna boot up VirtualBox. And gonna select the file there, boom, okay, click, start. So what's happening now is VirtualBox is reading this ISO file, and you can see this. It's loading now, right? In real time, it's like people streaming into us right now. And since I'm in Norway, I'm going to use nynorsk. And I mean, I can use this menu and I can like install it, and it's like kind of having a really slow network disk. So you know, this I clicked like 5 seconds ago, and it just works. I can't believe it. So I think that's pretty cool. So I'm just gonna cancel that. Oh, oops. Accidentally closed my slides. So that was my final demo. So if you're really into this, you should hang out on IFC, and you should follow Ferros, because he's trying to do these crazy things, but in the browser. And that's kind of like taking it to the next step using WebRTC, because that's going to be like, I like to say, democratized Bittorrent, because it's like bringing it to everybody at once. It's like going to be mind-blowing. So I think torrent stream and a lot of the WebTorrent stuff is actually made up of like 20, 30 modules. So contribute, come help out. We need all the people we can get to make this even funnier and better and change the world. That's my presentation. Thank you.
Right, you officially get a high five.
Oh.
And that was a shitty high five. We should try again. That's better. So Trygve put in a bunch of questions, but I think I'm concluding there's no questions for this. That was
really?
amazing.
Thanks.
That is like total mind blown everybody off, right? Another big round of applause. Woo!